Hello, welcome back. In this calculus video, I'm going to be going over implicit differentiation, shifting from related rates. Before I solve this problem, I recommend you try it yourself first. Without wasting any time, let's get into it. So question 6 says, find the slope of the curve at the point 2, -1, and our equation given to us is x squared minus xy plus y to the 7th equals 3. So before we get into solving with calculus, I want to review what slope is again. So as you've probably learned, slope is the change in y over the change in x. If you've watched my last few videos, I break down what the calculus notation d over d actually means. So I've said that if you see something like d and you have like a variable here over d and you have a different variable here inside the parentheses, this, let's just call the variable x and z, right? Or I'll use b and c, right? So all this means is this notation represents the change in b with respect to c. In other words, this represents the change in b as c changes. That's all the calculus notation means. So now let's apply that here. If we know that the change in y over the change in x gets you the slope, if we were to write that in calculus notation, it would be dy over dx. So this means for this problem, we're going to want to take the derivative with respect to x. So in this problem, we are solving for dy dx. And to find that, we have to take the derivative of this equation with respect to x. Alright, so let's solve that. Let's take the derivative of this equation. So let me write down the equation. Put down here. X squared minus xy plus y to the 7th equals 3. And we want to take the derivative on both sides, right? So realize here, let's look at this term by term. So if we were to take the derivative of x squared dx over dx, this just simplifies to 1, right? Because these cancel. So you can just take it normally using the power rule. So that would be 2x minus, before I move on, in all the other problems I did in my 2 previous videos on related rates, we were taking it in respect to time, right? That's why we had this notation, dx dt, and this just didn't cancel out. But in this problem, we're taking it, in this problem, one second, let me get rid of this. In this problem, we're taking it with respect to x, and the variable is the same when you're taking like the derivative of x squared, right? Because it's dx over dx, and that just cancels out to 1. And that's where the whole concept of implicit differentiation comes from. Okay, so that part's done. Minus, okay, for this part, remember, if you want to take the derivative of xy, you have to recognize that this is the product rule. Since this is the product rule, you should treat negative x as your first function and treat y as your second function. So by the product rule, the derivative of xy would be the first function times the derivative of the second function. So the derivative of y would be 1 times your dy dx. And let me just explain why again. Because in this case, if you were just looking at only y, you're taking the derivative. This would be dy dx. And since you're taking the derivative with respect to a different variable than y, it doesn't cancel out. So we have to attach this notation when we take the derivative here. Now let's move on to the second part of the product rule. So we did the first function times the derivative of the second function plus the second function, y, times the derivative of the first function. So the derivative of negative x is just -1. And we don't need to attach the label because we're taking the derivative with respect to x. So this is going to be -1. So this is going to be a negative y. Now, let's move on to, oh yeah, so that's all for the xy part, negative xy part. Now let's move on to the y to the 7th. Same thing here. Do the power rule. Imagine this was an x, 7y to the 6th, and then just attach your notation, dy dx. And the right side, the derivative of a constant is just 0, right? So now after this, we're solving for dy dx. So we can start to plug in our points. Start to plug in our point, 2, -1. So wherever you see x, plug in 2. And wherever you see y, just plug in -1. So 2 times 2 minus 2 times 1 times dy dx minus -1. And remember, if it's like this becomes a positive, plus 7 -1 to the 6th times dy dx, and you set that equal to 0. Boom. So now let's just simplify. So this is going to be 4 minus 2 times dy dx. And remember, this becomes +1 plus 1 plus 7, because -1 to the 6th is going to be 1, times dy dx equals 0. And in this case, now all you have to do is just combine like terms. Let me show you guys something first. So right now, the dy over dx notation might feel funky, but it's just like if you were to combine like terms, it would be like adding -2x plus 7x, right? Which is just 5x. You're just combining like terms. Same logic here. -2 times dy dx plus 7 times dy dx, it would be 5 times dy dx. So, and then also you would add 4 plus 1. So it would be 5 plus 5 times dy dx equals 0. Let me get rid of this. And now since we're solving for the slope, dy dx, get -5 to the other side. Get 5 to the other side. So you get 5 times dy dx equals -5. Divide by 5 to solve for dy over dx. And you get dy dx, which is your slope, as -1. So your answer to this question is -1. I hope that made sense, and thank you for watching.